Okay, so this is again sensation and perception. This is video 9. This is looking again at perceptual organization. This is the second part. We're going to look at depth cues and binocular cues in this section. So make sure you're again titling your notes monocular and binocular cues. So let's talk about the organization of three-dimensional things. How do we see in three dimension? Well, because of depth perception, the ability to see objects in 3 dimensions, this enables us to understand distance. So our body and our eyes allow us to understand depth cues. When seeing a car far away, you understand that it's going to get closer, the image is going to appear closer and get larger. That's because we understand depth. Depth perception, Eleanor Gibson and Richard Walk actually studied depth perception. They looked at the visual cliff, which was a laboratory device for testing depth in animals and young infants. It was like a miniature cliff. Okay, here appeared the platform, and then over here appeared a piece of glass. What they wanted to do is they put 6 to 14-month-old children on the platform to see if they would crawl off, okay, or go over the cliff. And if they knew that if looking down would cause them to fall because they would understand depth. Okay. Most believed, and they saw through research, that the time that they're actually mobile and able to crawl, their brains allow them to understand depth perception. And this only gets stronger with age. So the infants did not try and crawl onto the glass because they understood that there was a depth there that they didn't want to fall. We have 2 different cues. We have the binocular cues and the monocular cues. First ones we'll talk about is the binocular cues. Binocular cues are depth cues, specifically such as retinal disparity, that use 2 eyes in order to help us understand distance. So binocular cues are using 2 eyes, and with the 2 eyes we could actually understand distance. 2 eyes are better than 1 to understand the distance of different items. Retinal disparity is that our eyes are not at the exact same location in the face, so we see images a little bit differently. Because our eyes are 2.5 inches apart, the retinas receive different images. The brain computes the distance between them, known as this retinal disparity. Retinal disparity compares images from the retina in the 2 eyes. The brain computes the distance, and the greater the disparity of the distance between the 2, the closer the object is. So kind of a cool thing, you can stop and check this with yourself. If you hold your 2 fingers together right out in front of your nose, okay, and if you start moving it closer to your eyes slowly, okay, and you're looking straight ahead, you start seeing, okay, 2 different images, and you actually start creating like a little a hot dog finger in between you that's floating because retinal disparity, it's having a hard time processing that retinal disparity between the 2. So that's our monocular cues, using 2 eyes, understanding retinal disparity, but you can gain a lot of information by using monocular cues, which is using depth cues by using 1 eye alone. Okay, the first 3, the relative height, relative size, and inner disposition. And then the last 3, linear perspective, light and shadow, and relative motion. So by understanding relative height, okay, might be a good idea again to jot down the term and make sure that you have an example of the different images. So a monocular cue helps us understand the field of vision by the height of the images. The higher the image appears in the picture and environment, the further the distance. The lower it is on the page, the closer the image appears. So if you look at this image right now, what appears to be closer is the grass because it's lower on the page. Our brain begins to interpret this and understand this through experience. The clouds appear further away because they're higher on the page. Relative size. Another monocular cue helps us understand size of objects. If we assume already 2 objects are similar in size, the one that's smaller appears to be further away. So I could see that both of these Coke cans are the same size. But since the one on the left appears a little bit further away, okay, or a little bit smaller, I appear to assume that it's further away. Same thing with the pool balls. Okay, the one up close, they're all the same size, but the other pool balls must be further away because they're smaller. Inner position. So a monocular cue that helps us understand how close an object is compared to another, okay, is inner position. If one object particularly blocks our view of vision of another, we perceive the object on top is actually closer. So the blue object appears closer because it's on top of the red object. Okay, the blue crayon and the pink crayon right here in front appear closer up because it's blocking the other object, which helps create depth. Linear perspective is a monocular cue that helps us understand parallel lines, okay, of our focus. As the lines appear to converge, get closer, it helps us understand that objects are further apart. The more they converge, the further the objects. Light and shadows. When you add light and shadows to pictures, it also changes the depths of things. Okay, a monocular cue helps us understand the distance by using shadows and light. Given two identical objects, the dimmer one seems further away and the lighter image appears closer up. So when you shadow something, it appears to create it to have a distance to it, and the lighter one seems closer up. And you can see this in these two pictures here. This one appears closer than this one. Relative motion. Relative motion is the last monocular cue, a monocular cue that helps us understand movement. As we move, okay, objects that are stable actually also appear to be moving. Okay. Also, if you're riding on a bus, oftentimes you fix your gaze on some objects, let's say a house. The objects beyond the fixation point appear to be moving towards you. In actuality, they're staying the same. And objects in front of the fixation point appear to be moving backwards. Okay, and again, this is creating movement, even though the objects on the other side or what you're staring at are not moving. Okay, so make sure again you have each of the different monocular cues: relative height, relative size, interposition, linear perspective, light and shadow, and relative motion. Make sure you have an example of each of those in your notes.